जी
Bismillahirrahmanirrahim. We start today the nervous system, and first lecture will be on physiological anatomy of the nervous system. Nervous system is a communication and control system. It is communication and control system. Its functioning involves conduction of impulses. So functioning involves conduction of impulses. Impulse conduction provides information and gives directions. So it provides information and gives direction. Structurally, nervous system is of two types: central nervous system and the peripheral nervous system. Central nervous system and the peripheral nervous system. Central nervous system consists of the brain and spinal cord. Brain and spinal cord constitute the central nervous system. And peripheral nervous system consists of 12 pairs of cranial nerves, 12 pairs of cranial nerves, and 31 pairs of the spinal nerves. 31 pairs of the spinal nerves. Cranial nerves originate from the brain and become the part of the peripheral nervous system. Spinal nerves originate from the spinal cord and become the part of the peripheral nervous system. Functionally, nervous system is of two types: somatic nervous system and autonomic nervous system. Somatic nervous system and autonomic nervous system. Somatic nervous system, it supplies the general structures. It supplies the general structures like skin and skeletal muscle. Skin and skeletal muscles are supplied by the somatic nervous system. Autonomic nervous system, it supplies the involuntary effectors. Involuntary effectors like smooth muscle, cardiac muscle, and glands. Smooth muscle, cardiac muscles, and glands. These are supplied by the autonomic nervous system. Keep in mind that a nerve may contain motor nerve fibers and as well as sensory nerve fibers. Similarly, a nerve can contain both type fibers, somatic and autonomic nerve fibers are present in a nerve. You know, our nervous system contains neurons and specialized tissue, the neuroglia. Neurons and neuroglia, these constitute the nervous system. Cell bodies of neurons, proximal portion of the processes of neurons embedded in neuroglia constitute the gray matter. So gray matter consists of cell bodies of neurons and proximal portion of the processes embedded in neuroglia. This is the gray matter. And white matter consists of nerve fibers embedded in neuroglia. Consists of nerve fibers embedded in neuroglia. Brain is enclosed in the skull, the cranium. And we know brain is covered by three meninges: the pia mater, arachnoid matter, and the dura matter. So pia glia matter, arachnoid matter, and dura matter. These are the meninges covering the brain. CSF, cerebrospinal fluid, is present in the subarachnoid space. So CSF is present in the subarachnoid space. Conventionally, we divide brain into three parts: hindbrain or rhombencephalon. Hindbrain or rhombencephalon. Midbrain or mesencephalon. Midbrain or mesencephalon. And then forebrain or prosen, P-R-O-S-E-N, prosencephalon. So these are the conventional parts of the brain: the hindbrain, the midbrain, and the forebrain or the prosencephalon. Hindbrain consists of medulla oblongata, also called myelencephalon, pons, also called metencephalon, and the cerebellum. So hindbrain consisting of the medulla oblongata, pons, and cerebellum. This is the hindbrain. And medulla oblongata is also called myelencephalon. Pons is also called metencephalon. The forebrain. The forebrain consists of the cerebrum, which is also called the telencephalon. So telencephalon, or the cerebrum, the major part of the forebrain, and the other part of the forebrain is diencephalon. So these are the conventional part of the brain: rhombencephalon, the hindbrain, mesencephalon, the midbrain, and the forebrain, the prosencephalon. Now, just give you the basic structures of these parts of the brain and their main functions. First, we about the hindbrain. Medulla oblongata. Medulla oblongata is conical in shape, and it contains anterior median fissure you see, this is the medulla oblongata, and this is the anterior median fissure. You can see lateral to the anterior median fissure, these are the pyramids. These are the pyramids. One pyramid and the other pyramid. Posterior to the pyramid are the olives. You see? Posterior to pyramid are the olives. And posterior to olives are the inferior cerebellar peduncles. Inferior cerebellar peduncles, which connect the medulla oblongata with the cerebellum. Which connect the medulla oblongata with the cerebellum. Now, in the medulla oblongata, there are nuclei of 8th, 9th, 10th, 11th, and 12th cranial nerves. So nuclei of the 8th, 9th, 10th, 11th, and 12th cranial nerve: vestibulocochlear, the 8th nerve; glossopharyngeal, 9th; vagus, 10th; accessory, 11th; and hypoglossal, 12th nerve. In the medulla oblongata, there is portion of the vasomotor center, portion of the respiratory center, and then centers for salivation, vomiting and coughing, and center for salivation in the medulla oblongata. After the medulla oblongata, we come to pons. Pons mean bridge. It connects the medulla with the midbrain. This is the pons. It connects the medulla oblongata with the midbrain. Pons means bridge. Pons is connected to cerebellum through middle cerebellar peduncle. So connected to midbrain, to cerebellum through middle cerebellar peduncle. Pons contain nuclei of the 5th, 6th, and 7th nerve. 5th, 6th, and 7th nerve. 5th nerve, trigeminal nerve, has got 3 nuclei. So there are 3 nuclei of the trigeminal nerve: motor nucleus, principal sensory nucleus, and the spinal nucleus. 5th nerve. 6th nerve is abducent, and 7th is the facial nerve. In the pons, there is portion of vasomotor center, respiratory center, and also portion of the center for the control of the muscle group. So portion center for the control of the muscle group. The same center is present also in the medulla oblongata. So in the medulla oblongata and pons, both the center for the control of the muscle tone. So this was about the pons. Right? The next portion of the hindbrain is midbrain. Midbrain is a narrow portion which connects the pons with the brain, with the cerebrum. Now in the midbrain, there are ascending and descending nerve fibers. Ascending and descending nerve fibers are present in the midbrain. In the midbrain, there is a small aqueduct, also called cerebral aqueduct, or aqueduct of Sylvius. So in the midbrain, there is a cerebral aqueduct or aqueduct of Sylvius, which connects the third ventricle with the fourth ventricle. Posterior to aqueduct, the part of the midbrain is called tectum. Tectum is the part of midbrain posterior to the aqueduct. Now in the tectum of midbrain, there are 2 superior colliculi and 2 inferior colliculi. So 2 superior colliculi and 2 inferior colliculi are present in the tectum of the midbrain. Superior colliculi are involved in the reflex response to visual impulse, or to vision, or visual stimuli. So reflex response to visual stimuli is provided by the superior colliculi. Say, bright light is shown behind me. So my head and eye turn immediately back towards towards back to see the bright light. So reflex response to visual stimuli is provided by the superior colliculi. Inferior colliculi are involved in reflex response to auditory stimuli. So reflex response to auditory stimuli is provided by the inferior colliculi. So this was about the function of superior and inferior colliculi present in the tectum of the midbrain. Anterior to the cerebral aqueduct. Anterior to the cerebral aqueduct, the part of midbrain is called cerebral peduncle. Cerebral peduncle is the part of the midbrain anterior to the cerebral aqueduct. The cerebral peduncle is divided into two parts by substantia nigra. So cerebral peduncle is divided into two parts by a band of pigmented gray matter, substantia nigra, into two parts. Anterior is crus cerebri, and posterior is tegmentum. So crus cerebri and tegmentum, these are the parts of the midbrain anterior to cerebral aqueduct, and this division is by the substantia nigra, a band of pigmented gray matter, that is the substantia nigra. In the tegmentum midbrain, so in the midbrain tegmentum, red nucleus is present. So red nucleus is present in the tegmentum of the midbrain. Red nucleus is highly vascular mass of the nerve cells, and this is called red nucleus, and that is in the tegmentum of the midbrain. This was about the midbrain. We have discussed about the medulla oblongata, pons, and midbrain. What is brainstem? The brainstem consists of the pons, medulla, and cerebellum. So it consists of the midbrain, pons, and medulla. Midbrain, pons, and medulla, these constitute the brainstem. And these are the parts which remains when we remove cerebrum and cerebellum. We remove cerebrum and cerebellum, the left behind will be the brainstem. It consists of the midbrain, pons, and medulla oblongata. You see, this is the brainstem consisting of the midbrain, pons, and medulla oblongata. Midbrain, pons, and medulla oblongata. Now we come to the forebrain, consisting of the diencephalon and the cerebrum. Diencephalon is small part of the forebrain. It consists of mainly the thalamus and hypothalamus. So thalamus and hypothalamus are the main parts of the diencephalon. Then we come to the cerebrum. Cerebrum or telencephalon. Cerebrum consists of two cerebral hemispheres connected together by a mass of white matter, the corpus callosum. The corpus callosum. So cerebrum consists of two cerebral hemispheres connected by a mass of white matter, the corpus callosum. The corpus callosum. This is cerebral hemisphere. On the surface there is gray matter, and the inner core is white matter. Inner core is white matter. Cerebral cortex, composed of gray matter, is thrown into folds or gyri, separated by fissures or sulci. So cerebral cortex is thrown into folds or gyri, separated by the fissures or sulci. So the purpose of this folding of cerebral cortex is to increase the surface area. Is to increase the surface area with this arrangement. There are two important fissures or sulci. So two important fissures or sulci. This is the center sulcus, and this is the lateral sulcus. So center sulcus is also called fissure of Rolando. Also called fissure of Rolando, the center sulcus, and the lateral sulcus is also called Sylvian fissure. So Sylvian fissure is the other name of the lateral fissure. Cerebral hemisphere is divided into lobes by these fissures or sulci, and these lobes are named after the name of the bone under which the lobe lies. So these lobes are named after the name of the bone under which these lobes lie. Frontal lobe. Frontal lobe is anterior to center sulcus and superior to lateral sulcus. So anterior to center sulcus and superior to lateral sulcus is the frontal lobe. Is the frontal lobe. Posterior to center sulcus and superior to lateral sulcus is the parietal lobe. Is the parietal lobe. Inferior to parieto-occipital sulcus is the occipital lobe. Occipital lobe is inferior to the parieto-occipital sulcus, and inferior to the lateral sulcus is the temporal lobe. So frontal lobe, parietal lobe, occipital lobe, and the temporal lobe. You see fissure of Rolando or center sulcus, Sylvian fissure, the lateral sulcus, the frontal lobe, parietal lobe, occipital lobe, and this is the temporal lobe inferior to the lateral sulcus. Now, if you see the medial surface of cerebral hemispheres, we see a radiating or fan-like structure consisting of nerve fibers which enter and leave the cerebral cortex. So chroma radiata is a fan-shaped structures of the nerve fibers which enter and leave the cerebral cortex. We know in the inner core of the cerebral hemisphere is the white matter. Now in the white matter of each cerebral hemisphere, there are masses of gray matter, the basal ganglia. So basal ganglia are the masses of gray matter present in the white matter of the cerebral hemisphere, and these basal ganglia includes the caudate, putamen, globus pallidus, substantia nigra, and subthalamus. So these are the 5 components of the basal ganglia: caudate, putamen, globus pallidus, and substantia nigra, and subthalamus. In each cerebral hemisphere, there is a lateral ventricle present. So in each hemisphere, there is lateral ventricle present. The two lateral ventricles are connected to third ventricle through interventricular foramen. So the two lateral ventricles are connected to third ventricle through interventricular foramen. Right? So this was about the physiological anatomy of the brain. Right? I discussed the important parts. Right? Which cranial nerves come out through the medulla oblongata? 8th, 9th, 10th, 11th, and 12th. And which centers are present in the medulla oblongata? Portion of the vasomotor center, respiratory center, center for salivation, coughing, vomiting, and for the control of muscle tone, Which nuclei are present, trained nuclei are present in the pons. So in the pons, there are nuclei of the cranial nerves 5th, 6th, and 7th. 5th, 6th, and 7th. Trigeminal, abducent, and facial. And they are portion of the center of vasomotor center, respiratory center, and the center for skeletal muscle tone. And then, in the midbrain, which cranial nerve nuclei are present? 3rd and 4th. Oculomotor and trochlear. So, oculomotor and trochlear, their nuclei are present in the midbrain. Now, we mentioned about the 3rd and 4th nerve. What about nuclei of the 1st and 2nd cranial nerves? Now keep in mind, these two nerves, olfactory, optic, these are pure sensory nerves. These are pure sensory nerves. So the nuclei are not there in the brain, parts of the brain. These are pure sensory nerves, the olfactory and optic nerves. So this was about the physiological anatomy of the brain. Thank you.